Hello everyone, this is Riddhi Sudhiri and today we are discussing this problem, that is sum of root to leaf binary numbers. This is a very simple yet interesting problem. The problem says that you are given with a root of binary tree, and the only values that this binary tree is containing is zeros and one, and each root each path from this root to the leaf node of this binary tree represents a binary number starting from its most significant bit. And what you have to do is you have to return sum of all such numbers. Suppose this represents a number x, this path represents number y, this represents something x and all. So what you have to do is you have to return sum of all these numbers so on. So if things are not clear, let me explain you with an example, and let's see what we can do with this problem. So here is one such example that is demonstrated in the example. So let's discuss what I am trying to say in this question. So it says that first of all, let's make clear that what is a leaf node. Let's take another pen. So leaf node in a binary tree is simply a node which is the last node of any tree. I mean, it does not have any further childrens in a tree. So you can see that this is a leaf node, this, and this is a leaf node in a binary tree. And the possible paths from root to this leaf nodes are, I mean, very obvious that this could be a path, this could be a path, this could also be a path, and this could be a path of path from root to the leaf nodes. Now if you look closely, this path will represent a binary representation. This path will let's write these numbers or these paths here. This will be 1 0 0. This will be 1 0 1. This will be 1 1 0 1 1 0. This will be 1 1 1, right? And this is a binary representation of 4. This is for 5, this is for 6, this is for 7, right? Now these all are these all represent some number. Now what you have to represent, or what you have to return, is you have to return the sum of all these values, so found by taking the path from root till the path till the root leaf to the leaf node, sorry. So this, if you think of a brute force solution, it is very obvious that you will first of all travel from the root to the path to the leaf node, and you will start collecting this path in any array or string. And once you have completed this, you will then convert this array or string into its into its decimal representation, and you will do this for all the path that you get from root till the leaf node. And after that you convert them correspondingly, and you then sum them up to get the final answer. This but will be a very hectic solution, because you anyways have to travel all of these, and then you have to convert these things, and you have to traverse these strings, and you have to then proceed with this answer. So we are not going to do this much lengthy process. What we are trying to how we are trying to solve this problem is by running some method. So in this method, what we will do is we will at each step, let's take another pen for that. So at each step, what we will be doing is we will be maintaining a sum. This sum will hold the representation, the sum value till that node in the tree. So what I'm trying to say here is, suppose at this index, we are at this index, so we will be having a value in the sum variable which will represent the sum till here. And suppose we are at this position, we will again be having a sum variable which will hold the value for sum till this position. So how are we going to convert, or how are we going to get the sum for here? It's pretty simple. You have to just keep this in mind, that value at this spot, right? The sum at any node is the 2 times the sum at previous node plus the value at that node, right? In initially this value will be 0, because when we are starting we don't have any much sum. So suppose let's dry run this situation, and let's see if we can find out, or if we can get this answer or not. So initially, as we have took sum as 0, so at this node what we will be having is, we will be having 2 times 0 plus 1. So at this node sum will be 1. I'm writing this in boxes. These boxes value represents the sum at that node. Similarly, when we reach at this spot, we will be having is 2 times of initial value, 2 times of 1 plus 0. So that will be 2, right? Similarly, when we reach at this spot, initially the sum would be 2. So 2 times of 2 is 4 plus 0 is 4, right? Similarly, at this spot, we can, we don't have to travel from the start because this is the extension from this node. So we can consider this 2. So 2 times of 2 plus 1 is 5, right? Similarly, when we reach at this spot, 2 times of 1 plus 1, that is 3, right? Similarly, at this spot, you can see that we have to do 2 times of 3, that is 6 plus 0, that at that spot 6 will be our sum. Similarly, at this spot we will do is 2 times of 3 plus 1, that is 7, right? So if you look closely at each path, we have the correct value. This is 5, by the way. Yeah, so we have this correct corresponding value allocated at this sum variable. So now just what we have to do is we simply have to add all of these values to get our final answer, that is 22 in this case. Right. So this was the step, or this was the logic that we have to do, and rest of the things are very very simple. And if you have done previous questions with trees and recursion, so you might know what I am talking about, or how is this achievable. So which kind of traversal are we using? Obviously we are using recursion for that. So in this traversal we are using the pre-order traversal. And for those who don't know what pre-order traversal is, simply wherein first of all we target the node, then we hit its left side, and then we go at its right side, right? So this is simply the pre-order traversal. So we are using this pre-order traversal. So I'm not going into how this recursive call is working, or how we are shifting to this after calculating this value, how we are shifting to its backward node. All of this I am not covering because this is very simple or basic stuff regarding trees. So let's quickly jump into our code and let's see what we have coded, and if it submits our test cases or not. So clearly we in the given function we were not given any sum value, and we want our sum value to pass at every function call. So we have made a helper function for that, and initially we have passed 0 as the sum. And the base case would be ki we will check that if our root is null, so we will return 0 for that case situation. And additionally, one thing we will also be checking is that if we are on the current if at the current root, or at the current node, if it is a leaf node or not. What do you mean by leaf node is that it has no further children. So at each step we will check that if roots left and roots right both are null, we will simply return our existing sum, the sum that we have in this variable, right? And once we have checked all of this, additionally one more step that we will do at each node is we will use this running sum thing, right? We will do this we will multiply this current sum with it with 2, and we will add this current value that I've already discussed, that how should we proceed further, right? Sorry. Yeah, after doing that, once we have maintained once we have performed all these functions for the current node, what we had to do is, it's simple recursion stuff, that we call for its left node, we call for its right node, and we'll simply combine these two answer and we will return our final answer, right? In this situation you can see that we have made a call on its left subtree, and we have made a call on its right subtree. And suppose this is a sample node, so this will be its left node, this will be its right node. So we will at this step we will make a call on its left tree, we will make on right tree, we will make a call on right tree, and we will add these answer and we will return this thing, right? So this was the simple stuff. Let's run this answer and let's see that if it passes our basic test cases or not. So it does passes our basic test cases. Let's submit this. Great. Our code gets submitted. So this was the explanation for this code. So if you like this solution, you can like this video and you can consider subscribing to the channel as well. So this is for this video. That's all. Bye bye everyone.